Hi guys, and welcome to Cisco Live and this Master Series class on AI and machine learning. My name is Robert Barton, and I'm a distinguished architect with Cisco, obviously working in the area of AI and machine learning. So today we're going to talk a little bit about this technology, we're going to demystify it a bit for you, and we're going to talk about what is Cisco doing in this space and making it so interesting, worth talking about. Well, I think we're in the city of Barcelona here at Cisco Live, and when we go to the most famous street of Barcelona, it's La Rambla, and at the bottom of La Rambla is this statue of Christopher Columbus. Now, in the year 1492, we all know the story, he left for his voyage of discovery, he went to the New World. A year later, in March of 1493, he came back here to the port of Barcelona. He was met by the King and Queen of Spain, and he started to tell his stories about what he had discovered. And without a doubt, this was the most disruptive event of the 15th century, probably of the entire millennia. Think of all the changes that happened because of this voyage of discovery. Well, Christopher Columbus and the King and Queen of Spain, probably all the people that had met him, really had no idea the impact that this discovery was going to have, and yet it changed the world. Well, today we're seeing a similar type of disruption, and that is artificial intelligence and machine learning. Everyone's talking about it. Everyone has an opinion on it. Most people don't really understand it. They can only basically tell you some ideas about it, maybe some from the movies, but they really don't know much about it. But it really is something that is going to change the world, and it is already doing so to many, many companies. In fact, it's hard to think of a company or an industry that is not being disrupted by artificial intelligence. Sometimes friends will get around to the coffee shop and say, name a company, name an industry that is not being affected by AI. Even traditional ones like the taxi companies. These are disrupted by Lyft and Uber. The video services companies being disrupted by Netflix and other types of online video services. They're AI engines that are really changing the way we interact with each other, with products, the way we talk to customers, and Cisco is no exception. We see this list of products here, it's just a sampling of the area where Cisco is using AI, both for our own intelligence and for our own products to make them better, but also to serve our customers better and support their machine learning workloads. If we look at the four fundamental pillars of Cisco's strategy, one is about our applications and the networks we run them on, securing our data, transforming our infrastructure, and finally empowering our teams through things like communications and WebEx. These are the four fundamental things that drive all the product development at Cisco, and every single one of them actually has a lot of AI built into it. It's hard to even think of a Cisco product now that doesn't have some relation to AI, either using the data from the network to make the network smarter, or again, helping our customers with their AI problems. So let's talk about what this means. What exactly is AI and machine learning? We'll just take a few minutes to describe it, and we'll maybe take away some of the complexity. And then we're going to explore exactly how Cisco is using this in a few major product areas and categories. So we've heard about machine learning. Machine learning is about taking data, training algorithms, and helping them to make decisions without being explicitly programmed. That's what machine learning is all about. But actually, it's part of a bigger world called artificial intelligence. So we'll use these expressions almost interchangeably, AI and ML. Well, they're very related, but they're actually a little bit different. So just like when a human has to learn something before they can do it, a certain task, whether it's something like riding a bicycle, you have to learn first before you can really do it well. Well, it's the same with computers. You have to learn and be trained to do something before you can go and do it. So that's the difference between machine learning, is you learn first based on historical data and training data, and then you go and you execute it in the wild. That is true artificial intelligence. There's a special class of machine learning that gets a lot of attention in the media called deep learning. We say deep because it's very, very deep and important, but it's actually just a class of machine learning that does some very, very cool things. It gets the attention because it makes machine learning much, much faster than it ever has been in the past. And even though machine learning as a science has been around since the 1940s, deep learning is solving problems and letting us do things that were just never possible before. So it gets all the attention. In fact, we at Cisco are using deep learning, also called neural networks, in many, many different product categories. And I'm going to show you some examples of these in just a few minutes. Well, let's just take a little bit of a snapshot. What some of these main methods of machine learning are. We'll just look at 3 of them and help you understand where we would apply these types of different algorithms and what sort of problems they're able to solve. The first major class of machine learning is called supervised learning. This is when you have a lot of training data, a lot of historical data, and you use it to train an algorithm so that it can predict something that it's never seen before. Now, in the world of machine learning, data scientists, they love to use examples of pictures of animals, and for some reason they love cats and dogs. So let's say we take lots of pictures of cats and pictures of dogs and other animals, and we label them, this is a cat or this is a dog, and we give thousands upon thousands of pictures to our algorithm. Eventually, by looking at the pixels and the formation of the pixels, it gets trained so that one day when we show it a new picture that it's never seen before, it can tell us it's a cat or a dog. So we typically call this an A to B mapping. And again, it's based on historical data. And the more training data you can give to an algorithm, usually the better it gets. So you need a lot of data to make this effective. In fact, we often will say that data is the rocket fuel for machine learning. If you don't have a lot of data, it's hard to train those algorithms to make them useful. So keep that in mind as we go through our discussion today. The second class of machine learning is called unsupervised. So the first one was supervised based on historical data, and we're leading to a particular mapping. Whereas unsupervised learning, we're not really leading to a mapping. We just have a big jumble data, a collection of data points. We really don't know what it means, but there's a hidden pattern in there somewhere. Well, it's very hard for the human eye to pick out patterns that are in very high number of dimensions. If you're looking at 4 to 5 dimensions, even 500 or 1,000 dimensions, how can a human look at all the patterns and really understand it? Well, there's value in that data, but machines are really good at finding what those patterns are that are just unseen to the human eye. Well, that's what unsupervised learning is all about. Finding what the patterns are, finding where the cluster boundaries are, and very importantly, as we'll see in the world of security, figuring out where the outliers are. The thing that just sticks out like a sore thumb that just shouldn't be there, the anomaly, that's what unsupervised learning is really, really good at. So think of it as a way to look at patterns and understanding the boundaries of where those patterns are, as opposed to supervised learning where we're actually trying to predict something or map one thing to the next. Now that third class I want to talk about is deep learning. And this is a very, very important one because it's able to solve problems that we just couldn't do before. Now deep learning uses this idea of layers, where you have an input layer and the output leads to another layer. And at each layer, there's little things called neurons. And the idea is that this type of machine learning mimics as close as possible to the way that humans think, or so we theorize. Probably we don't think exactly like this, or the brain doesn't work exactly like this, but this is a general concept of perhaps how we can display in a computer mechanism the way the brain is functioning. And the idea is, when you make a decision, you have a series of inputs. And these inputs have certain weights. So for example, you're going to go on vacation next summer. Where are you going to go? Well, you have certain criteria, like how much it's going to cost, how far you're going to travel, how many days off work you have. These are parameters or input variables, and you give a weighting to each of these. Now you multiply your input weight by the variable value, and then you lead it from one decision criteria to the next, and eventually you lead to an output. Now the value of deep learning is that it lets you do a lot of this computation in parallel. So it means you can come to your result very, very quickly. And deep learning allows us to do things like natural language processing, where a computer can understand your speech and you can translate it for things like Alexa and Siri and Hey Google. All these capabilities are because of deep learning. Or computer vision, where you can identify an object or a human face and you can identify what they're doing. That's all because of deep learning. So think about it as breaking this complex job of machine learning into a lot of little small ones and processing them in parallel. So is this supervised learning or unsupervised learning? Well, it can actually do both. It has that kind of flexibility and power, which has really made it one of the most popular types of machine learning today. Okay, so the stage is set. Those are the types of technology we're dealing with, the type of algorithms involved. Let's explore how Cisco is using them. So I want to start in the data center because that's where we start to process all that data. Now, an important concept to understand is what's the difference between a CPU and a GPU? Well, I think we all know what a CPU is. That's the processor that goes in our computers, in our phones. We use them almost everywhere. It's like the Swiss Army knife of computing. It can do almost everything. Because it's a reduced instruction set type of architecture, it's really very, very flexible. Now, a GPU, or a graphics processing unit, is a bit different. It's a specialized type of processor. The GPU was actually invented for the video game industry by NVIDIA in the late 1990s, very specifically for pixel manipulation to accelerate video graphics in games. Well, it turns out GPUs are very, very powerful when it comes to machine learning. So they're not like the CPU that's the Swiss Army knife. Think of them more of the specialized instrument that a surgeon might use. Now, if you were going in for an operation and you were lying there on the table and they're going to do some surgery on you, and the surgeon walked in with a Swiss Army knife and he was ready to start surgery on your body, I think you'd be running for the door. This guy is not using the specialized instruments. No, he's not even trained to be doing this. Well, in the world of AI machine learning, primarily we use GPUs because they're specialized for that task. So if we try CPUs, they would work, but they're really not optimized and they won't be that fast for this type of operation. So GPUs are really the central thing for machine learning. Well, what is it about the GPU that makes them so useful? It's their ability to do parallel processing. So whereas a CPU might have a couple of cores, you might have a dozen cores even on a fairly powerful CPU, the GPU, by contrast, has hundreds, if not thousands of cores that let you process a whole bunch of things all at the same time. Now, do you remember in deep learning, we have lots of these input variables and we have lots of layers? In real machine learning networks where we're looking at images, for example, in self-driving cars or language processing, you could have thousands of input variables. If you were to do that in a CPU and look at each variable one by one by one, it would take a very, very long time to process that, probably not even making it very useful. Now, a GPU can process a whole bunch of them all at the same time. So imagine a different core inside of this GPU having a different input variable or a neuron in that deep learning network, and it processes it all in one clock cycle. That's the power of the GPU, and that's why we want to use it in a lot of these types of machine learning jobs. Now, is the GPU the right type of tool to use for a serialized task, something that doesn't need a lot of parallel processing? Well, of course not. You would not use a GPU for that. You want to use the right tool for the right job. That's one of the key aspects of any type of technology. Well, let's take an example for image analysis. So here we have multiple layers. We look at 4 input layers into our deep learning network. We have these things in the middle called hidden layers. These are the middle processing layers where the output of one leads to the input of the next. Now, if we apply this to image analysis, perhaps we're just starting with a picture of a face. Well, the first layer is looking at the edges. So where are the dark to light edges of this particular image of the person? The next layer, we look at objects like the ear, the nose, the mouth, aspects of the face that tell us features exactly what we're looking at. The next we get more and more refined, and as we go through these layers, we can very quickly get to a definition that this is a human. We can even identify who that is, perhaps even more details about them, like their emotion based on the facial expressions that they're making. Now, in this diagram, we're only showing 2 internal or hidden layers. In reality, it's going to have a lot more, but this is a very useful aspect of parallel computing because I can do all these pixels, one after the next, one does not relate to the next, and I can get to my output, and allows me to get a result from this A to B mapping. Now, just as a little anecdote, some time ago, at the Google data center, they thought, this whole deep learning thing, this is a really great tool to do image recognition, and this was one of the first examples. They said, let's build a cat detector. And again, data scientists love to find images of animals and to map them. It's sort of a subculture in the world of AI for some reason, but you'll find a lot in this space. So at the Google data center, they built this cat detector, and they built it with over 1,000 servers, with 16 cores each, so 16,000 cores, looking at all these pictures of animals. The estimated cost of this infrastructure was the minimum $1 million US, probably was much, much higher, but the cost of the powering of these servers in the data center, it was huge. 600 kilowatts of power being required for these 1,000 servers. that's a very expensive cat detector. Why would anybody build such a thing? Well, of course, this was a scientific experiment. But then the researchers over at Stanford's AI lab got hold of some GPUs and they said, well, there's probably a much, much better way to do this because we don't need the heavy lift computing of a CPU. All we need to do is a very simple matrix operation in these little cores of the GPU, and we can do this whole thing in parallel. So over at Stanford, they got just 3 servers with a total of 18,000 cores because of their GPUs. Only cost them $20,000, and they did the exact same thing. Well, the good news is that everyone can build their own cat detector now, almost for no cost, because we have these types of things on the market that are very, very inexpensive. This just shows you the power of the GPU when it comes to AI and machine learning. So what is Cisco doing in this space? Well, the leaders in the GPU space are, of course, the processor companies like NVIDIA. They lead in this space. Cisco has partnered with NVIDIA. In fact, what we see here is the UCS 480ML. So this is a server that's stacked with NVIDIA Tesla V600 or V100 GPUs. This one server has over 5,000 cores in it. It's meant to do a lot of parallel processing, so if you have to do image analysis, speech recognition, noise cancellation, any of these type of typical machine learning, deep learning type of projects, this is the server you would buy. You would not buy this server for just a regular off-the-shelf application. This is very, very specifically built for the world of AI and deep learning. So this is an example of a product we build to help our customers with their AI projects. And of course, we have to partner with companies like NVIDIA because Cisco doesn't design these types of processors. There's other companies as well that build processors like Intel and AMD, and even Google has processors they have built very specifically called tensor processing units. So we'll see a lot of this developed as we go forward, but again, it has to be a very specialized server. Well, what about in the campus? What about in enterprise networking? What is Cisco doing in this space? Well, we announced last year something called DNA analytics. When you think about machine learning, uses data like rocket fuel. This is what fires the algorithms. It lets it predict the certain events as they occur. It does these mappings of A to B. It finds these cluster boundaries, these anomalies. Well, you need a lot of data to be able to do that. When we look at the network, it generates an amazing amount of data about itself. This is not the data you just pass through the network. This is the data that the network is generating from telemetry, whether it's syslogs, or it's SNMP data, or it's NetFlow data, or it's firewall logs. These are events that the network is recording about itself. Well, no one's really looked at all this data holistically and started to apply deep learning techniques to these types of data. But what if we could? What if we could start to collect data from our own network and then compare that with everyone else's network? What if we had a way to look at every big network around the world and start to collect this together and start to see what makes the network perform well, under what conditions does it start to fail, a wireless network, when do people start to lose connectivity? This is a very classic machine learning type of problem. When we look to things like the automotive industry, they've been doing this for a long time. The robots and the machines that are on the production line, they collect data from those machines so they can predict when that machine is going to fail or when a part is going to break. Well, we can do the same thing in the network now with DNA analytics. It lets us do different types of machine learning to do root cause analysis, do predictive maintenance when part of the network is about to fail for some other reason, and it tells us even when our performance is suboptimal. This was a project called Kairos, and the intent of Kairos is to build a cloud data repository that pulls in data from our customer networks all over the world. So as customers start to deploy DNA Center, they generate data about their networks. The Kairos cloud allows us to pull this data and anonymize it. So we don't see anything that's unique to the customer, we don't even see their IP addresses, we just collect metadata about what's going on and the performance of that network. Now, as we start to collect this network data, we apply it to machine learning models. We train those models to understand the behavior of that network. And under all these input variables, what's making a certain network perform well and a different one perform poorly. And we start to get a clean idea of how networks will behave with all these different environmental variables at play. So let's take an example of how Kairos works. So let's say you have an issue with your wireless network and for some reason performance is just not good. Everyone is saying your Wi-Fi is terrible, let's call Cisco TAC. And what's Cisco TAC going to tell you? Okay, Mr. Customer, I'm sorry, you have to go do a site survey again. And you say, no, I've done a site survey. I am telling you, a site survey is not the problem. I'm still having wireless performance issues. People are taking a long time to connect. Their performance is terrible. Well, site survey is not going to necessarily help you with performance issues. There could be a lot of things at play. You could have some type of collision issues. You could have contention issues on the wireless domain. There could be quality of service issues. Who knows? There could be a million different variables. But what if you apply DNA analytics and you apply these machine learning models? Could you tell what the root cause of that problem is and perhaps even warn the customer as it starts to occur and before it becomes an issue and is apparent to all of those users? Well, that's exactly what DNA analytics is all about. So take this example here of some analytics that DNA Center has given to us. So you see this top band, we see this green band that fluctuates up and down. Well, this is given to us through a machine learning model. Based on all the data that we're getting from the environment, from the wireless access points, from the controller, from just the number of clients that are on, the type of applications they're using, and measuring their performance, we can come up with an estimation of what the predicted performance of that network should be under those conditions. This is a predictive algorithm that is the output of a machine learning tool. And primarily, this is a regression technique that uses deep learning. So we see what the predicted band here, this green band up and down. Now, do you see that little line that's going through this green band? That's what our actual performance is. Now, at some point, the line goes underneath the green band. It tells us that you have worse performance than you would expect with these type of environmental variables. Based on the conditions we see your performance is dipping below. Other times, it looks normal, it's right in the middle of the green band as we would expect, but we're really interested to know, why did it dip below? Why is our performance poor under certain conditions? Well, that's where we need to do some root cause analysis. So first we're using regression and deep learning techniques to understand the expected behavior of our network. Now we compare it to what we're actually seeing, then we start to look for anomalies. We start to use some unsupervised learning techniques to actually understand where are the anomalies? Where are those outliers that are just shouldn't be there, they're performing for some reason in a poor way. Now, here we see different examples of signal strength, of signal to noise ratio, and very quickly in that little band we see in the middle, we can see where things have dipped down, and we can identify quickly it's a signal strength issue. So very quickly we're using data now in a powerful way to help us understand the actual performance of our network. Let's look at a third area where AI machine learning are being used a lot at Cisco, and that is in the world of collaboration. When we think about collaboration, we think about WebEx and telepresence suites and these immersive rooms. These are using computer vision. Computer vision is a field where we're using deep learning to look at objects, to identify what they are, to understand what is being said in some cases. We can even talk to our WebEx boards and communicate with them like you would with Siri, Alexa, Google, these types of things. We can now do the same thing with WebEx. And there's a host of capabilities in most of our WebEx and telepresence systems. Well, what enables this? Do you remember the technology? It's the GPU. Without the GPU, you cannot easily do computer vision, natural language processing, and these types of capabilities. So every Cisco WebEx board has one of these GPUs built into it. This is the Jetson GPU built by NVIDIA. It's the same type of GPU that gets put into self-driving cars, autonomous vehicles, and it lets us do a tremendous number of interesting capabilities. Now, here's an interesting one. Have you ever been on a conference call when people have a lot of background noise, perhaps an ambulance goes by or a fire truck, or perhaps people are typing on their keyboard and they forgot to put themselves on mute? That's one of the most irritating things to me. Tap, 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 tap. And you're just like, who is the person that's typing on their computer? Can we just mute that person? Well, wouldn't it be nice if the AI system in that conference could detect that? Could see that this is one of those anomalous noises we just don't want to have on our system, or if there was a barking dog or some type of disruptive noise that's common, that's well known, and we could just cancel it out. Well, this is again where we're using AI. Now, do you remember we talked about image recognition is something we use deep learning for, to identify images, to identify exactly what it is? Well, when we look at spectrograms of sound, we can display these as images as well. So for example, the pattern of a human speaking is very different from a dog barking, or a siren of an ambulance, a fire truck, or a police car, or the tap, 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 tap of the keyboard. It has a certain cadence that identifies it uniquely as that type of a sound. So at Cisco, what we do is we train our WebEx system in our engineering. We know what these types of sounds are. We classify it with thousands of samples of dogs barking, of sirens, and we put that into the system and we do detection of it. And we detect it through a deep learning network. And what do we do when we hear that or detect that type of sound? Well, we send out a cancellation noise that will prevent that from being sent across the WebEx, across the conference call, so other people are not disturbed by that particular sound. It's a very, very useful application of deep learning embedded directly into our collaboration tools. Well, another capability is identification of the people on the video conference. Have you ever been on a video conference and there's these other people in the room and you know you recognize these people, but you just wish someone would introduce themselves so you could attach a name to the face? Well, this is a very common problem. You're not alone. We've all experienced that. With AI face recognition in our WebEx system, we're actually able to look into the directory, and we've actually deployed this at Cisco using our own directory system and the images of people's faces. So when you're on the WebEx, it will actually show the name of the person below their face, and you know exactly who it is that you're talking to. Of course, I'm not sure if it's been tested for people who are twins and look extremely similar. They might get it wrong in certain cases, but AI is pretty good. It can detect even micro differences between people that's hard for the human eye to pick up, but an AI system with computer vision, especially when it's in HD, is able to pick up these differences, and you can tell who you're speaking to, and you don't need that formal introduction and hopefully not embarrassing yourself. Well, computer vision is a fascinating subject, and these applications of AI almost seem limitless. Just across the way here, across the road, there's a display that WebEx has of the sentiment analysis. So you can walk into the booth and it can tell you a lot of things about you. The emotion that you're expressing. Are you happy? Are you sad? Are you calm? Are you nervous? Are you tired? In fact, I tried this just before I did this broadcast, and it was pretty accurate. It told me exactly my age. It told me my gender. Good thing we got that one right. And it could tell me if I was happy or sad. And then I tried to scowl and tried to be really angry face, and then it says you're angry. So it seemed to be pretty accurate in picking up the sentiment. And my buddy that I did this with, he's like, why would you ever use this? Like, who is ever going to use a sentiment analysis? Well, imagine you're a teacher in a classroom, and you want to see if you're being effective as a teacher. So you point your camera back to the class, and now you can see the sentiment of the students in the classroom. Are they enjoying the material? Are they bored out of their minds? Are they falling asleep? Well, the AI can tell you and can give you an average sentiment score for all the students that are in the classroom. Well, that's pretty useful. That can help the teacher understand he needs to kick it up a notch or he's doing a good job. It also brings up some interesting questions of potential bias. This is a very important area of AI where we can start to see aspects of a person which actually might lead to discrimination. So in the world of research and AI, a lot of the academic research is going into how can we actually remove bias when we see certain people displaying certain traits. For example, if we look at perhaps the criminal population, do they look a certain way, and are we trying to identify people who are completely innocent as criminals? Well, we may not have designed our AI algorithm to be discriminatory or to show bias, but by the training set we give it, are we leading it to a biased outcome? There was a fascinating story at one of the largest tech cloud companies. They were filtering their resumes and using a deep learning model to look at all the words in the resume. And what they would do is compare it with successful candidates who had got jobs at this company, and they would use this filtering mechanism to automatically get rid of the resumes that were just not suited or not likely to become successful employees. Well, guess what happened? In this company, the majority of the workers were males. So the AI algorithm, by the data it had been fed, started to conclude that you had to be a man, a male, to work at this company. Of course, that is not a very good outcome. It's very, very biased. Females are just as qualified as men, but just because of the training data it was fed, it was leading to the wrong conclusion. So after the company realized this, they went back and they started to make some changes, and well, we have to train this algorithm differently. That wasn't our intent at all. But even then, subtly, the language that was used, typically in the resume that's put together by a man versus a woman, is different. And because of that, it started to pick up these differences and say, well, again, this is the type of resume you need to be successful. Well, these are traps that we can fall into with AI systems, and we want to avoid them. So how do we do that? It's still a bit of an art, and it's being researched. We as humans don't want to be biased and show discrimination, but sometimes the data we feed into these algorithms can lead us to these biased results, and it's something that you really have to watch out for if you do an AI project. A last area we're going to look at is AI in the world of security. And perhaps this is one of the most important and impactful areas for Cisco in using AI. Well, when we look at the landscape today, we see the number of attacks that are out there. It's very, very difficult to stop them. And one of the biggest reasons is that so much traffic is encrypted. If we look at the amount of traffic today on the internet that's encrypted, it's well over 80%, leading to 90%. We may hit the point one day that almost 100% of traffic on the internet is encrypted. Well, how do you find the malware and the nasty attackers if they're all inside encrypted traffic? It's very difficult, isn't it? Look at this picture here. Do you see the assassin laying in wait to hit someone? Well, it's very hard to tell. It all looks exactly the same, looks like a bunch of rocks. But if you look very carefully, there is an assassin in there, and he's holding a rifle, waiting to shoot. This is the kind of problem that security architects and security analysts have to face in the world of IT today. How do you find the malicious attacker? Well, it turns out you don't necessarily have to look just at the inside of a packet. You can look at the behavior of a packet. We often say that 90% of communication is nonverbal. In other words, you can look at the way a person thinks by the way they move their head. Perhaps their body language. It says so much about them, their eye contact with you. It tells you really what they're thinking, if they're interested in you. Turns out we can do the same thing with network analytics. If we look at the behavior of traffic flows, if we see the behavior of certain metadata, the size of packets, the space between packets, where their source is, where their destination is, the type of traffic at the headers, that will tell us so much about the traffic itself that we can start to identify it. Now, what type of machine learning do you think we're using here if it's anomaly detection? Well, again, we're looking for outliers, those anomalies. This tends to be unsupervised learning. So we're looking what those anomalies are, things that's just out of normal. It doesn't seem to be normal traffic flow. That's probably your attacker. That's the one who's trying to do something nasty on your network. So we look at these linear decision boundaries, and the way we find these boundaries is through the magic of unsupervised learning. We feed a lot of data, we look for the clusters, and we see what's healthy versus what is dangerous on our network. And it's a first line of defense, really, in identifying what the nasty things on the network are. Once we've classified it as an outlier, then we can look at other types of machine learning, regression techniques and deep learning techniques to really classify what it is and why this anomaly is trying to do something nasty on our network, and then feed it back even to firewall rules and other types of intelligent network systems that will stop that malware and stop that threat actor. One of the examples of this is something called Etta, or encrypted traffic analytics. What Etta does is takes net flow information, so a lot of the information from the header of the packets, metadata about the packet, and we send it back to StealthWatch. Now, the ASIC underneath that allows us to do this is something called UDPA, or Doppler. It takes all this information, sends it back to StealthWatch, and we feed it into these machine learning models. We then look at classification of this. We look for whether it's benign, whether it's nasty. We classify it as an anomaly, and then we pass it into more machine learning tools to say, we need to stop this or we let it go. Well, how effective is encrypted traffic analytics? Well, turns out it's very effective. In a lot of testing, we've been able to find 99.9% accuracy that something is nasty without even seeing inside the packet. Just by looking at the behavioral analytics of the packet, we can tell what it's up to, what it's trying to do, and whether it should be prevented from our network. So we've looked at 4 different areas of machine learning and AI, how Cisco is using it. It's probably just the tip of the iceberg. We've been down this AI journey for a couple of years now, and we're already using it almost in every product we have across our business units, product categories. We looked at just 4 different areas, from collaboration to the data center, to enterprise networking, to security. AI is really becoming a foundational tenet of our technology, and it's extremely exciting, I think, what we're doing today and what we're going to do in the future. So hopefully you've enjoyed this Master Series class and learning a little bit about the fundamentals of AI, machine learning, and how we're using it, and hopefully you take something away from this and you can enjoy learning more about it in the future. Thanks guys, and have a great day.